When I'm in nature, I see mathematics. The sun, the sky being blue, you see the clouds forming that contain all these droplets. Everybody's trying to capture the essence of what governs the world around us. And the best way to capture that, instead of having words, is an equation. An equation, a mathematical equation, is truly the universal language that transcends fields, transcends ideas, but also transcends cultures and countries.
Imagine a phage as like a cruise missile that only hunts and kills members of one very unlucky family. When a phage finds its victim, it connects its tail fibers with receptors and uses a sort of syringe to puncture the surface. In a weird motion, the phage squeezes its tail and injects its genetic information. Within minutes, the bacteria is taken over. It's now forced to manufacture all the parts of new phages. They only stop when the bacteria is filled up with brand new phages. In the final step, they produce endolysin, a powerful enzyme that punches a hole in the bacteria. The pressure is so high that the bacteria sort of vomits out all of its insides and dies. New phages are released and begin the cycle anew. In the last few years, bacteriophages have enjoyed the attention of the second deadliest beings on Earth, humans.
You watched our last episode, and really, if you haven't, you should. You now know all about derivatives and how to use them to describe the way an equation is changing, which means we can now talk about the other main part of calculus, basically the inverse of derivatives, called integrals. Integrals are useful because they also tell you a lot about an equation. If you plot an equation on a graph, the integral is equal to the area between the curve and the horizontal axis. Finding an integral is a little less straightforward than finding a derivative, but as with derivatives, there are shortcuts we can use to make things a little easier. We'll even be able to use integrals to talk about how things move, specifically the equation we've been calling the displacement curve, and why it looks the way it does. So let's get started.